Hello students. You're welcome to today's chemistry lesson. We will be studying chemical combination, part 1. But before we begin, let us have a recap of our previous lesson. In our previous class, we learned about the law of constant composition, which explains that a chemical compound always contains the same elements combined in the same fixed ratio by mass. We also learned about the law of multiple proportions, which explains that when two elements combine to form more than one compound, they do so in simple whole number ratios. Lastly, a chemical equation is a short way of representing a chemical reaction using symbols and chemical formula. Our lesson objective for today is to learn the first 20 elements of the periodic table and examine the electronic configuration of their atoms. The periodic table is a special chart that shows all chemical elements. In this class, we will study only the first 20 elements. Here are the first 20 elements of the periodic table in order: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. These elements are very important because they form many substances we use every day. Electronic configuration of atoms tells us how electrons are arranged in an atom. Electrons move in shells, also known as energy levels. The principal energy level of an atom is represented by numbers such as 1, 2, 3, up to 7. These numbers correspond to the periods on the periodic table. As the number increases, the energy level also increases. Letters like S, P, D, and F represent subshells, also called sublevels. For example, in 1s superscript 1, the number 1 shows the principal energy level. The letter S shows the type of orbital or sublevel. And the small number 1 shows how many electrons are present in that orbital. The lowest energy orbitals must be filled first. For example, the 1s orbital is filled and then we can fill the 2s orbital and go on to the 2p orbitals. From there, the filling of orbitals continues in order of increasing energy. Here are the electronic configurations of the first 20 elements. Take your time to listen and understand. Hydrogen has 1 electron, so its electronic configuration is 1s1. Helium has 2 electrons. Its configuration is 1s2. Oxygen has 8 electrons. Its configuration is 1s2, 2s2, 2p4. Sodium has 11 electrons. Its configuration is 1s2, 2s2, 2p6, 3s1. And so on for the remaining elements. Take your time to go through the rest of the elements carefully for better understanding. A bond is the force that joins atoms together to form a substance. There are two main types of bonds: strong bonds, which hold atoms tightly together, and weak bonds, which are easy to break. Under strong bonds, we have electrovalent bond, covalent bond, and metallic bond. An electrovalent bond is a type of chemical bond formed when one atom completely gives out one or more electrons and another atom completely receives those electrons. This transfer of electrons causes the atoms to become charged particles called ions. The opposite charges attract each other, holding the atoms together in a strong bond. This type of bond usually occurs between a metal and a non-metal. For example, sodium, which is a metal, loses 1 electron to become a positive ion, while chlorine, a non-metal, gains 1 electron to become a negative ion, and the attraction between these opposite ions forms an electrovalent bond. You're making progress, keep it up. A covalent bond is formed when atoms share electrons with one another. This type of bond usually occurs between non-metal elements. Example, water, H2O. In a water molecule, each hydrogen atom shares 1 electron with the oxygen atom. At the same time, oxygen shares its electrons with the hydrogen atoms. By sharing electrons in this way, all the atoms become stable, and a covalent bond is formed. A metallic bond is formed between metal atoms. In this bond, the outer electrons are free to move from one atom to another. These free electrons hold the metal atoms together. For example, in aluminium, the atoms are held together by metallic bonding. Each aluminium atom releases its outer electrons into a pool of free-moving electrons. These electrons move freely between the aluminium atoms and hold them together. This is why aluminium is strong, shiny, and a good conductor of electricity. You have completed this lesson. You're making excellent progress. Let's answer a few short questions to help us remember what we've learned so far. In today's lesson, we learned the first 20 elements of the periodic table, which are the most commonly used elements, starting from hydrogen to calcium. We also examined the electronic configuration of atoms, which explains how electrons are distributed in different energy levels, also known as shells. In our next class, we will continue with chemical combination, part 2. Thank you.